When we talk about the cartels formed by firms in an oligopoly market, the kind of behavior is collaboration or collusion between the firms. But in Cournot model, or the so-called Cournot monopoly, we are considering non-cooperative behavior by the firms. To start, we first look at a very simple Cournot model, that is a duopoly. We have two firms in the market. These American Airlines and United Airlines are the only two firms in this market for the flights from Chicago to Los Angeles back and forth. These two airlines decide their quantity of output, or thousands of passengers per quarter, to fly independently and simultaneously. The number of passengers flown by American Airlines is QA and by United is QU. The quantity supplied to the market is capital Q equal to QA plus QU, that is thousands of passengers per quarter in the whole market for the flights from Chicago to LA back and forth. In panel A of figure 11.2, we first consider what will happen if American Airlines is the only supplier in this market, that is, American Airlines is the monopolist in this market. And we assume a linear demand curve with an inverse demand function P equal to 339 minus Q, the total quantity. And then we know that the marginal revenue will be 339 minus 2Q. This is the marginal revenue curve. For both American Airlines and United Airlines, we assume a constant marginal cost of $147. Given this marginal cost for American Airlines and this marginal revenue for the whole market, because we assume American Airlines is the monopoly, then the monopolist output is 96, and the ticket price will be 243. To see the monopolist calculation, we know that the marginal revenue equal to 339 minus 2Q, and that will equal to the marginal cost at 147. So what we have is 2Q equal to 339 minus 147 equal to 192. And then the monopoly output quantity, let's put little m here, will be 192 divided by 2 equal to 96. So that's how we get the monopoly output quantity. And go back to the inverse demand function minus Qm here, and then we have 339 minus 96, that is 243, which is the market price when this market is a monopoly market. So that's how we get 96 as the monopoly quantity and 243 as the monopoly price. But this market is not a monopoly. We have a competitor for American Airlines. That's the United Airlines. And then the American Airlines has to consider the so-called residual demand, which is at a certain price, the quantity demanded faced by American Airlines is the total market quantity demanded minus the supply at that price by the competitor. This O here means other firms. Other firms supply certain quantity at this price P, and the demand left, the so-called residual demand faced by American Airlines here, will be the total quantity demanded at this price in the market minus what other firms supply to the market at this price. And in particular, here we just consider this total quantity demanded by the market minus the quantity supplied by the United Airlines, because there are only two firms. This is so-called duopoly, just two firms in this market. Then we consider a special case. Let's say the quantity offered by United is 64. So the residual demand faced by American Airlines will be this 339 minus 64, which give us 275. 275 minus Q will be this residual demand DR faced by American Airlines. Then the residual marginal revenue curve MRR will be 275 minus 2Q. Again, American Airlines will try to maximize its profit by equating its marginal cost to its marginal revenue curve MRR here. So it's 174 equal to 275 minus 2Q. And then by the similar calculation we have done in the monopoly market, we will get the new quantity supplied by American Airlines to this market will be 64, QA equal to 64 as well, when American Airlines is trying to maximize its profit under this residual demand curve. And the market price will be $211. Now let's look at that calculation. So when the quantity supplied by the United Airlines is 64, the residual demand function for American Airlines is QA equal to capital Q minus QU, which is 339 minus P minus 64. Then we have 275 minus P. This is the demand function we have obtained, or say the residual demand function. Then the inverse residual demand function will be 275 minus QA here. So what we have learned before for the monopolist is that if you have this inverse demand function, then the marginal revenue function will be the same intercept, 275 minus 2 times the coefficient on the quantity, which is 1 here. So just 2 times 1, that's 2 times 2QA. Again, the marginal cost curve is still 147. Now, to maximize profit, the American Airlines would need to equate this residual marginal revenue curve with its marginal cost curve. So we have 2QA, the American Airlines quantity, which assumed QU equal to 64, and that will equal to 275 minus 174, which is, use your calculator, you will get 182. So QA here is actually 182 divided by 2 will be 64. This will be the quantity provided by American Airlines when it assumes the United Airlines will send 64 units to the market. After we have obtained the quantity supplied by American Airlines, we need to consider what will be the price in this duopoly market. So the total quantity supplied by United and American Airlines is 64 plus 64. It's 128, equal to this total market demand curve, 339 minus P. Then the price equal to 339 minus 128, we have $211. That's how we get this quantity. Once the quantity supplied at 64 by the United Airlines is assumed, we have calculated the profit maximizing quantity for American Airlines, which is 64. Then we put American Airlines 64 units and United 64 units back together to the total market demand curve, this 339 minus P, we get the market price of $211. What we are looking at in figure 11.2b is one example of one best response. What it says is that given American Airlines believe that United will produce QU equal to 64, American Airlines will face a new residual demand function and a new residual marginal revenue function. And given that residual marginal revenue function, American Airlines can maximize its profit by using our profit maximization rule, marginal revenue equal to marginal cost, to determine the profit maximizing output quantity, which is 64. And then we see a market price of $211. That's the end of this reasoning. What it says is that the output quantity of United Airlines is assumed, and then given that condition, American Airlines try to do its best. So it's a best response. But this quantity supplied by the United Airlines is not necessarily the best response to this output level 64 by the American Airlines. We will look at that point more closely later on. But what I need to emphasize here is that this initial quantity here is one assumption, just one assumption only. It is not the simultaneous best responses from both firms. It's only a condition for American Airlines best response. And if the United Airlines change its quantity supplied, American Airlines will have different best responses for the changed value of QU, the quantity supplied by United Airlines. So in this picture, if we shift this residual demand function from D, this light blue line, to lower and lower and lower, we will have a sequence of different profit maximizing QA, the quantity supplied by American Airlines, determined by American Airlines using the marginal revenue equal to marginal cost rule when it's trying to maximize its profit. Figure 11.3 shows us the best response curves for both American Airlines and the United Airlines. Again, one best response curve is the quantities set by one airline given the airline's belief about the quantities supplied by the other airline in the market. And this airline is setting its quantity supplied to the market using the marginal revenue equal to marginal cost rule, or the profit maximizing rule. Now let's look at the axis first. On the horizontal axis is the quantity supplied by American Airlines, and on the vertical axis is the quantity supplied by the United Airlines. We have calculated one best response for American Airlines. That is, given the assumption of 64, American Airlines should produce a QA equal to 64. So the 64 point is on American's best response curve. If the quantity supplied by the United Airlines QU is 0, we have seen that in that situation, the American Airlines will be the monopoly in this market, and the monopoly output level is 96. So QA equal to 96 when QU equal to 0, the monopoly output. And then if QU equal to 64, QA set by American Airlines will be 64 as well. Finally, if QU produced at 192, which is the quantity supplied at a price that equal to the marginal cost of 147. So if you use 339 minus 147, price equal to the marginal cost, we will get 192. What United Airlines is doing is to set the price at the marginal cost, basically making no profit, and flooded the market with 192 units, make it unprofitable for American Airlines to supply any quantity to the market. So American Airlines' best response when United sets its output at 192 is 0, QA equal to 0. What happens is that the quantity supplied to the market is so high, drive the price equal to the marginal cost. If American Airlines supply another 1 unit into the market, that will drive the price down below the marginal cost and make everybody in this market losing money on every unit that they are selling because the price in the market is below the constant marginal cost. So when United is setting its output level so high that make the price equal to the marginal cost, the best response for American Airlines is to set its output level to 0. QA equal to 96 and QU equal to 0, QA equal to 64, QU equal to 64, QA equal to 0, QU equal to 192. These 3 points are all on this best response curve by American Airlines. Because in this example, we have assumed that these two firms are offering identical products and they have identical cost structure. That means they have the same constant marginal cost here. The result is that we can use symmetry. What's true for the best responses of American Airlines will also be true for the best responses for the United Airlines. So the United best response curve will be this mirror image around a 45-degree line of the American Airlines best response curve. Now we actually see this point, 64, is the so-called Nash Cournot equilibrium point. Yes, I have said that 64 for American Airlines is a best response to the United's output quantity of 64. That's only from the standing point of the American Airlines. But it turns out that from the view of the United Airlines on this green line, if the American Airlines decide to supply 64 units to the market, United also maximize its profit at 64 units. So this is when both firms cannot increase their own profit by changing their output anymore. So both firms have maximized their profits by setting their output quantities equal to 64 units. This is the so-called Nash equilibrium here. This is when the best response of the American Airlines meet the best response of the United Airlines. Both firms are at their best response to each other's decision. Then it's a Nash equilibrium situation. Now, if we give the firms a bit of time to figure this out, for example, if it starts at QA equal to 96 and QU equal to 0 at this point, American Airlines is assuming a monopoly's position and United is producing nothing fly nobody from Chicago to LA or back and forth. Then United will see, well, American Airlines supplying 96 units. My best response is actually to supply 48 units. So after United observed 96 units, it will bring up output to 48. Then we reach this point B of QA equal to 96 and QU star equal to 48. And then American Airlines look at the output level set by United 48. American realize I should be able to improve my profit by setting a lower quantity. Now from 96 drop to 82. Because this point B, is not on American's best response curve. American Airlines best response curve tells American Airlines that when United is producing 48, it should produce 82. But QA equal to 82 and QU equal to 48 is not on United's best response curve, so United actually increase its quantity a little bit, given American Airlines is producing at 82. And then American Airlines figure that, well, given this higher United quantity supplied, I should reduce my quantity supplied to the market according to my blue best response curve, and then eventually the equilibrium reached at QA equal to 64 and QU equal to 64. Nobody changes. If we start from another point, QA equal to 0 and QU equal to 96, it's not on Americans' best response curve, so Americans will actually increase the output. Given that increase, the new American output, the United Airlines will decide to decrease its output. And given this new lower output level by the United Airlines, American Airlines will increase its output again. Again, starting from this side, it also reached the equilibrium at QA equal to 64 and QU equal to 64. That's why this is an equilibrium. No party in this competition would like to unilaterally change their behavior, because both parties have reached their own best responses to each other's best responses. Now let's look at the calculation. The market demand function is capital Q equal to 339 minus the price. Then the residual demand function for American is QA equal to 339 minus the price minus QU. Or we really need to use the inverse demand function, so price equal to 339 minus QA minus QU. That's the inverse demand function. From Chapter 9, we have seen that if you have an inverse demand function, price equal to A, which is a constant, minus B, a coefficient, times Q, then the marginal revenue function is P equal to A minus 2 times the slope B times Q. And we know that A and B are both positive constants. A is the intercept on the vertical price axis, minus B is the slope of the linear demand curve. Then for American Airlines, we actually assume QU is just another constant. So the intercept for the residual marginal revenue curve will be 339 minus this constant QU, then minus 2 times QA. The 2 come from this double here, and QA just have 1 as coefficient, so 2 times 1 times QA in the marginal revenue function for American Airlines when it facing this residual demand curve. Once we have obtained the residual marginal revenue curve, we need to look at the marginal cost so that we can decide the profit maximizing quantity. The marginal cost for both firms are constant, and that means the marginal cost equal to the average cost equal to 147 per passenger per flight. Now, if we equate the marginal revenue with marginal cost, we have 339 minus 2 times QA minus QU equal to 147. So QA equal to 339 minus 147, we have 192 divided by 2, which is the coefficient on QA, minus QU itself divided by 2. This profit maximizing condition give us American Airlines best response function, that is QA equal to 96, which is 192 divided by 2 minus a half of QU. Similarly, United Airlines best response is QU equal to 96 minus 0.5 times QA. These two best response functions meet at the Nash-Cournot equilibrium. So we need to solve these so-called two equations for two unknowns. Basically, the way we can solve this so-called system of two equations and two unknowns is to bring the expression of one unknown into the other equation. So we bring this expression about QU into the American Airlines best response function. So QA equal to 96 minus 0.5 times QU. Now replace this QU with 96 minus 0.5 times QA. So it's QA equal to 96 minus 0.5 times 96 minus 0.5 times QA in parentheses. Then we will get a result. So what we have done is that we replaced the quantity supplied by United by an expression of it as a function of QA. I will times this 1/2 on both sides of this equation. So I have 2 times QA equal to 192, which is 2 times 96, minus, in parentheses, 96 minus 0.5 times QA. And that equal to 96, because I have 192 minus 96, which is 96, plus, minus, and minus sign, I have plus, 0.5 times QA. This gives us 2 minus 1.5. I'm moving this 0.5 QA to the other side, and that requires a change of sign. Or say I minus 0.5 QA on both sides of the equation. So let me show you that. 2 QA minus 0.5 times QA equal to 96 plus 0.5 times QA minus 0.5 times QA. And that's why I said if you consider moving this term on the other side of the equation, you just flip its sign. Because we know that after we have minus the same thing on the right hand side here, this term is 0. So it's 0. So we just flip the sign of half QA, then we can move it onto the other side of this equation. Now what we have is 1.5 times QA equal to 96. So QA equal to 96 divided by 1.5, which give us 64. That's how we solved this equation for QA. And basically by symmetry, we can say, because United and American, they both have the same cost structure, they face the same market demand curve, They are producing the same product, identical product. So QU in this market is also 64 for the so-called Nash Cournot equilibrium. And we have calculated before, when the total market quantity is 128, that is 64 plus 64, the market price is $211. This is how we get 64 and 64 as the Nash Cournot equilibrium, and when we have this 128 total supply into the market, we have a market price of $211. So if we use calculus, the initial steps are the same. We have the market demand function capital Q equal to 339 minus P. Then the residual demand function for American is QA equal to 339 minus P minus QU. So the inverse residual demand is P equal to 339 minus QU minus QA. This is the price American Airlines face if QU is assumed for a certain quantity. Then American's revenue will depend on its own quantity supplied, which will result in a market price. And that price times the quantity it supplied will be the American Airlines revenue. So price determined by this inverse residual demand times the quantity it supplied. That will be the American's revenue function. It is 339 times QA minus QA squared minus QU times QA. Then to get American's marginal revenue function, we differentiate this total revenue function for American Airlines with respect to its own quantity supplied, QA. That gives us 339, just to the first power, just leave the constant here, and minus, move this second power down as the coefficient times QA itself. So QA come from QA to the second power minus 1, right? So that's QA itself. And then again, we assume QU is a constant. This is a constant times QA, just like 339 times QA. We have 339 here. For QU times QA, we have QU. So for the American Airlines, its residual marginal revenue function is 339 minus 2QA minus QU, just as what we have seen before. Again, because the two firms are basically identical in every aspect, the revenue function for United is 339 times QU minus QU squared minus QU times QA. Then the United Airlines residual marginal revenue function is 339 minus 2QU minus QA. To reach the best responses, we only calculated the marginal revenue function, right? The best responses rooted from the marginal revenue equal to the marginal cost. And once we get the best response functions from the two firms, in this case, on this slide, we use this system of two equations and two unknowns to solve for QU and QA simultaneously, and we get the same solution. Finally, if we think about increasing the number of firms in the market, let's say there are n firms, then the best response function for any firm is Q equal to 96 minus 0.5 times n minus 1 times Q. Then we can solve for the quantity supplied to the market because all the firms are assumed identical. You see, we don't have any subscript on the individual firm's quantity. So we can solve for this quantity. It will be 192 divided by n plus 1. The total output will be the individual firm's output quantity times 192. And that will be 192 times n over n plus 1. The market price will be 339 minus 192 times n over n plus 1. We can ignore how do we get this best response function, but once this best response is achieved, the rest of the calculation is straightforward. Given the previous result, we can see that if there's only one firm in the market, we will have a monopoly outcome. That means the quantity supplied by this one firm will be 96 and the price will be 243. If there are two firms in this market, the total quantity supplied will be 128 and the price will be $211, which is our duopoly outcome. As n gets large, n over n plus 1 is getting closer and closer to 1. So that means the output quantity will get very close to 192. And the market price will be very close to 147, which is the competitive outcome. The market price equal to the marginal cost for all the firms in this market. So what we have learned from this Cournot analysis is that when more firms compete in the market, the markup the firms can charge will be lower and the price goes towards the marginal cost. In figure 11.4, we consider what will happen to the original Nash-Cournot equilibrium if the marginal cost of one firm, in this case United, declines. So our assumption is still that the two firms offer identical products, the flights between Chicago and Los Angeles. However, rather than have 147 marginal cost, now United Airlines has a marginal cost of $99 per passenger per flight. Notice that this picture, the panel A of figure 11.4, is not the profit maximization problem for American Airlines, but it is for the United Airlines. So we actually still look at a residual demand curve, 339 minus 64, the output quantity by American Airlines minus P. 339 minus 64 minus P. That is 275 minus P. That's the residual demand curve faced by the United Airlines when American Airlines offer 64 units of output to the market. And the marginal revenue curve still look the same as before. The only thing that is different is this marginal cost curve. Instead of at marginal cost of $147, now the marginal cost curve declined to $99. That means given this marginal revenue curve, United would like to produce 88 units instead of 64. Now you can see that on the best response function for the United, when American Airlines offered 64, before the decline of the marginal cost, United would also like to offer 64, and that's the old Nash-Cournot equilibrium. However, now because United has a lower marginal cost, its optimal quantity to produce given QA equal to 64 is 88. This is actually the new point on the new best response curve by United Airlines given this lower marginal cost, MC2. And notice this point is actually not the new Nash-Cournot equilibrium. Rather, it's E2 here, where the new United best response, dark green line, and the American's best response, blue line, meet. At E2, we have American Airlines produce 48 units, but United actually supply 96 units into the market. Now let's look at this new best response curve by the United Airlines. At this point, the American Airlines is producing 240 units. We can ignore whether that makes sense for American Airlines at all. This is just assume that American Airlines is producing at that quantity, and that actually gives us a market price of $339 minus $240, $99, which is the marginal cost for United. And the reasoning by the United Airlines is that, well, the American Airlines has supplied so many units into the market, the price will be lower than my marginal cost if I start to supply any quantity into the market. So if the United Airlines supply one more unit to this market, the price will become $98, and that will be below the $99 marginal cost for United. So when the American Airlines supplying 240 units into the market, the profit maximizing decision for United is actually to produce nothing, set its own quantity at 0. Now at this point, United assume that American Airlines is producing nothing. They supply no quantity to the marketplace, and then United will be the monopoly in this market. So we are actually looking at this whole market demand curve, light blue line, and the $99 marginal cost. This point gives us a quantity of 240. And because the United Airlines is the monopolist, we know that the marginal revenue curve has twice the slope of the demand curve, so it will hit the quantity at half point of this total quantity. And from 0 to 240, the middle point is 120. That will be the monopoly's profit maximizing quantity. So we can imagine a marginal revenue curve slope down like this, and it actually hit the middle point between 0 and 240 on this red marginal cost curve. That's where the marginal revenue meet the marginal cost for the monopoly United Airlines when United believes QA equal to 0. So this is the monopoly output for United. QA is 0. United provide 120 units to the market. We can link 0, 120, and 240, 0 together. That's the United Airlines new best response curve. And this new best response curve meet American Airlines old best response curve at E2. The reason that American Airlines best response curve does not move is because its cost is still at 147, and given that 147 marginal cost, the best response forming decision is as before for American Airlines. What we are looking at is that in the Cournot duopoly, if one firm has a lower marginal cost from MC1 to MC2 for United here, the total market output now is higher. Before, when both firms produce 64 units, the total output is 128. But now, one firm produces at 48 for American, and United supply 96 units. The total is 144 units, and the price has become $195, dropping from $211. The output quantity raised and market price declined. That's actually good for the consumers. Just for one firm has a lower marginal cost. We also can see that the firm with lower marginal cost, United here, produce twice as much as the American Airlines. So in general, the firm has a lower marginal cost will produce more, and the firm that has a higher marginal cost will produce less. But the total output in the market actually increase and the price decline. So in general, even in non-competitive market, if some firms' marginal cost decline, it's beneficial to the consumers.